The answer? Okay. Astitva. Nobody has answered except Astitva. देखो, this is a very simple question, Vachu, and you are taking a lot of time to solve it. It seems like you have not revised and not done the homework as well, right? Everyone, please do search on the videos. Nobody has switched on the video, and it's like, why? Yes, everyone. Is there like, should I remind it again? I don't know. Farhan has left, also left in the middle of it. ठीक है, Irshad. Okay. Safia, Sara, Sri. Are you there, Sri?
Yes, sir.
So I only have the the single way to interact with you. That's a video. And if I also don't have that thing, so how would I know that you are attentively taking the class or not? Right. So please, it's a request. Whenever you're in the class, just be seated like a normal class that you sit like in the in the schools as well. Okay. Okay. So जल्दी से इस क्वेश्चन को सॉल्व करते हैं. The question is saying that a car being driven by a force of 2.5 into 10 to the power 10 Newton, traveling at a constant speed of 5 meter per second. ठीक है. It takes 2 minutes to reach a certain place. It means that 2 into 16, that is 120. Yes or no, everyone? ठीक है. So you can see this thing F is equals to, sorry, we need to calculate the work done. So but you can see this thing that B T is given to you, and it's a constant speed. We have to calculate the distance. So distance is nothing but speed into time, because we need to calculate work done. Speed into time. ठीक है. So speed into time. Do you remember this thing formula? Yes or no?
Yes, sir.
So that would be speed is 5. Because it's a constant speed. It's not changing at all. It's like not accelerating. So it's a constant pace, speed. You can use this formula, okay, into 120. So that would be in the 12 fives are 60 and it is 600 meter. Okay. So work done is nothing but force into displacement. So this was the formula. Now tell me, is this the question or is this the concept that we have not done it yet? Tell me which one.
Third.
We have done this type of concept. Sorry, 600. So that is 2.5 into 6 is 15. 15. So 1.5 into 10 to the power 13 joules. Is that clear to all of you? This is the answer. Okay. So Astitva gave me the Astitva 13, 14 होगा ना? देखो 2.5, 12 and 1 decimal is taken, so that would be 13 na?
Oh, yes, sir. One mistake. Yeah, I corrected.
Okay, that's good.
Okay, sir. Got it.
Chalo, let's do the next topic. Potential energy. Okay, so now let's understand what potential energy is. So there you go. First of all, I have told you that so for the first thing about the potential energy is that potential energy is because of the change in shape and change in position. Two factors are there in the potential energy. Okay. So potential energy is due to the change in shape and the change in position. So you must have seen this thing that if I have a body, if I have any object and if I take it to some height, so I'm doing work done against gravity. Yes or no? So where will that work done will go? Like where will it go? If I'm doing some work done, that energy, it should be somewhere. It will not destroyed, obviously, because energy neither be created nor be destroyed. It will get transferred. But what you so that energy will transferred into the body as a potential energy. That work done will be stored as a potential energy in that body, right? Okay. And suppose if you're stretching, what do you say gulel in Hindi? Just a second. Let me check on the internet. Um, catapult. Catapult. Have you seen a catapult? Catapult that we use to throw the basically stones, very small stones, in the base for basically birds or basically for fruits. Not birds specifically. That would be very harsh. For fruits. Okay. So that catapult is basically so when you stretch it, so there is an elastic energy stored in that. So that is also a potential energy due to change in shape. Okay.
Yes, sir.
Sorry. Just a second. Let me have a sip of water. Okay. Let's do it. Okay. So let me write the potential energy definition. Okay. Like everybody have like, is there anyone who is having like who is not having the law conservation of energy? No one. Everyone is having the gravity law of conservation of energy.
Yes, sir.
Chalo, theek. Because in the last session, the some schools have or some schools don't, so that's why. So see this thing, the energy of a body due to its position or change in shape known as potential energy. So potential energy are of various type, like elastic potential energy, gravitational potential energy. Okay. Okay. So the energy that is due to the position above the ground is called gravitational potential energy. And the energy that is due to the change in shape is called elastic potential energy. Okay? Due to its above ground. Okay? And the energy that is due to the change in shape is called elastic potential energy. Okay? Due to change shape. Is that clear to all of you?
Yes.
Okay, that's great. So basically, in normal day-to-day life, we use just potential energy instead of gravitational potential energy or the elastic potential energy. Okay, just we use normal. Okay, so our body may possess energy when it is not in motion. So that energy is called potential energy. Okay, clear everyone? Say yes or
Yes, sir.
no. Chalo, that's great. Next is,
Yes.
Acha, one more thing is that so kinetic energy and potential energy are related to each other in some manner, not related basically, like in terms like suppose if a body is moving, so if the body is in rest, so maximum potential energy will be there in the body. But when it will be start moving, so the amount of potential energy will decrease gradually and the amount of kinetic energy will increase gradually. So basically the energy, so the total part potential energy is going to convert in kinetic energy after some time. So that's how they are relatable to each other. So the sum of potential and kinetic energy is called mechanical energy. Okay? That's what we will understand in the law of conservation of energy in the next topic. Okay? So I'm writing it over here. The sum of something potential energy and kinetic energy board of a body is called its mechanical energy. Yeah. Okay, so the next thing about the formula of the potential energy would be, so basically, as I've told you, the gravitational potential energy. So the body, the potential enough energy of a body is due to its higher position above the earth because when we work done against the gravity, so that work done is basically is converted into potential energy and gets stored in the body itself. Okay, so that would be nothing but work done against gravity. Is that clear to all of you?
Yes, sir.
Is due to higher position above the earth. What? To the work done on the body against gravity. ठीक है, gravity moving the body to that position. Please do let me know, everyone, is that clear to you or not?
Yes, sir.
The potential energy mgh. ठीक है बच्चों,
Yes, sir.
mgh. So this is nothing but the formula that is your same that we have done in the class of work done against gravity. ठीक है, potential energy is equals to mgh. Okay, so now let's do the question based on that. So the question would be very similar to that one that we have done in the work done against gravity. Okay, so would you like to try this basic question, everyone? Yeah. Nobody said yes. It seems like nobody is interested, huh?
Yes, sir.
Don't worry, bacha, I'm there now. I will help you, but at least try to build the confidence to solve the questions. Okay. Yeah. Please let me answer, everyone.
So what is the SI unit of potential energy?
Think a little bit. Energy.
Yes,
So
sir.
energy is potential energy. Potential energy. So it's a type of energy. So SI unit would be joules. That's the thing. I've told you that any energy that we are taking right now, potential, kinetic, work done. So it's basically nothing but your energy. Okay, I got the answer by C. Let's one. अस्तित्व ठीक है श्री. Okay, that's the basic one. Very good. ठीक है. And let's do this question. ठीक है. So mass ठीक है. G, G is equals to meter per second square, height of 5 meter. ठीक है. So potential energy is denoted by P is equals to mgh or PE लिख लो आप. You can write PE instead of, because you will get confused that whether it is momentum or the potential energy. So P dot E. ठीक है. 1 into 10 That is equals to 50 joule. That's great. Try to solve this question, Isha. This one. And after this class, everyone, you'll be having the assessment. Okay, Stitva. Pass, everyone. Okay, Safia. Okay, Stitva. Okay, Sri. Sri, where were you in the last class, Vijay?
Yeah, I was there, but I joined like late.
That's chicken. Okay. So is it clear to you, Sri? Which I'm okay, chicken. Did you revise? Did you revise?
Yeah, a little.
A little. Partial, huh? I don't know. Like in 1 week, you said sir with just partial. How much I think so not more than 1 page we cover in single class, 1 or 2 page. And you said sir very like a little bit. That's not good. Chalo, Chiki, anyone left? Farhan, Sarah, any answer? Rishad? Like everyone, see this thing. Question is saying that a bag of wheat is given that weighs 200 kg. So it's not weight, it's mass. 200 kg is given that. To what height it should be basically taken to have the energy, potential energy as 9,800 joules. Okay. So that would be mass. Okay. And G. Okay. And okay. Okay. This will get cancelled by 1,000 times. Okay. Sorry. So h would be equals to equals to 5 meter. Any doubt so far to you, Bicha?
No, sir.
Okay. Acha. Try to find this question, Bicha. I just okay, Satva. Only single answer from Astitva, nobody else. Okay, Safia. Safia, Irshad, Sarah, any answer, Bicha? Okay, so it seems like no, only two have got the answer. Okay, देखो. So mass 200 gram. So it is 200 by 1000. So it would be point kg. ठीक. 5 meter. Sorry, this is h. Sorry, not m. ठीक है. potential energy is equals to mgh point 2 into 9.8 into 5. So that would be 9.8 joule. Okay. So as we know this thing that total energy is equals to sum of kinetic energy plus potential energy. Okay. So we have potential energy and total energy because the object was at the some height. So there was no motion. So obviously total energy will be equals to potential energy. Yes or no? So 10 total energy this is equals to 0 plus 10. So total kinetic and total energy of a body was 10 joule. Okay, above the ground. Here it is above the ground. When it will basically fall. Okay. Now when the object is falling, so in that case, sorry, it's not 10, it's 9.8 na. Sorry, that's my bad. 9.8. Okay. So potential energy at highest point is equals to kinetic energy at lowest point. Okay. Okay. So your kinetic energy 9 joule. Is that clear to all of you? Okay, so
Yes, sir.
this question, let me know the answer for this one. Okay, that's one. Anybody else? Sarah, Irshad, Safia, Farhan, please let me know the answer. Only two students gave this answer so far. Please let me know the answer, Bacha. It's the very simple question. This question is based on the motion chapter, Bacho. I'm giving you the hint as well. Dekho, let's solve it. Mass of a body is 10 kg, which is dropped from a ladder. Okay. And uh, G is equals to 10 given to you meter per second. Okay. And height of the ladder is 5 meter. So we have to calculate the velocity with which it will hit the ground. Okay. So velocity can be calculated as everyone because it is dropped. So the initial velocity would be 0. So v square minus u square is equals to 2as. Okay. This one would be the answer. And this one is v square minus 0 is equals to 2 into 10 into 5. So that would be 10 into 10. So v square would be equals to 100. So v would be equals to 10 meter per second. Yes or no, everyone? Is that clear to all of you? Any doubt so far to anyone?
No doubt, sir.
Okay. And now you can just now you can calculate the kinetic energy or not, Irshad and Sarah. Sarah, Irshad, are you there, bacho?
Yes, sir.
Can you calculate the kinetic energy now if the velocity is given to you? Okay, so this is the yeah. Irshad, find let me know the answer. I'm also calculating, but I want the answer from you as well. Okay, so kinetic energy is nothing but the half mv square. Okay, half mass is 10 is 10 is 10. This will get cancelled by 5 times. So this would be 100 into 5. So that is 500 joules of kinetic energy before it will hit the ground. Is that clear to all of you, everyone, so far in the class?
Yes, sir.
Any doubt? Okay.
No.
So with this topic, the potential energy is done. Only two topics are left. The one is the total energy, conservation of energy, sorry, and the power. So both topic will be covered in the next class, and that will be the last class for this topic. Is that clear to all of you? Please do let me know.
Yes, sir.
Doubt? Any doubt to anyone?
No, sir.
Sure?
Sure, sir.
Sure, that's great. Just allow me a second. So because there is no numerical in the total, sorry, law of conservation of energy, that's a very straightforward definition based topic. So only 2 or 3 lines will be there. So we will be defining the law of conservation of energy. Then we will be basically I'll be basically giving you an example when the body is going from a height to the downside. So how much energy is basically changing from one point to another. I think so we have done this thing in the free fall as well, if I'm not wrong. Just a second. That is gravitation, free fall. I think so. I've given the example for that portion. Just a second. The ball one example. Just just a second. I think so. Name. I've not given it. चलो कोई बात नहीं. No, I think so that portion will be covering in the work done. Okay? Clear everyone?